My NEET class is there, but showing some other class going on. Check it once, otherwise I'm ending this meeting. Okay, alright guys, so we were looking into integration, the integral in the last class. Alright, so I hope all of you are clear on the integral. You can respond yes or no. Murugasan, any doubt in the integration? Many? Okay, fine, that will take up later. What about you? Okay, which concept? Okay, alright. Whether I thought that you are coming online today, that's good if you came offline. Good. Okay, so integration we are done. Whatever queries, questions you have, we will take up later. Alright, so now what we are going to learn? Application of integral. Now there is only one single application of integral in your syllabus. That is, we'll be seeing how to find out area under the curve. Area under curve. So this is the one and only application of integral that we are going to study. All right. Now, what we'll be doing in this? Now, this chapter is very, like, I'll say one of the easiest chapter. You just have to be careful regarding what can be the limit and so on. Like how to find out the limit, what all can be the limit, like this. So we will be again restricting ourselves to only and only NCRT. All right. So one second, guys. I'll open up the NCRT so that we can follow exactly that. We need not to do anything extra. Neither we have time for that. Our aim is to get how many marks in term two? How many? 35 minimum, not 35. Minimum 35. All right. You can also get 40 if you want to. All right. And if the examiner want to give you. All right. So it will be mix of both. 1 second. All right. So first of all, what is definite integral? So in definite integral, although we have skipped limit of sum, but the idea was that if we have this curve and if we are integrating from point A to point B, or if we write this definite integral, that is A to B f of x into dx, then we say it gives us this area. If this is the graph of obviously y equal to fx. Now, why does it give this area? Anyone? Integration? Integration is sum. Now, what kind of sum we are doing? Like, see, if I add, I should get a number, right? Why we are getting area? Or how we do that basically? We take small rectangular strips and then we add all of that. So what we are assuming over here is that we are splitting this into very thin rectangular strips such that the width of each rectangular strip is dx. Now what is area of rectangle? Height into width. So dx is the width and height is y coordinate. What is y coordinate? F of x. So like this, if we keep on adding, then we get this area. Now, in definite integral, what happens is that whenever we are integrating, we integrate with a sign. With the sign in the sense, this is positive y above x-axis. But if I'm integrating this from here to here, this is negative y. In this case, definite integral will be negative. But when we talk about area can never be negative. Area can never be negative. So whenever we are finding out the area, the one of the most important part is that we always have to take the mod. We always take the mod. So if you do not know how the graph is means the graph can be like this. Something similar to a sine graph. If you do not know how it is. So the more proper way of saying that area bounded by the curve y equal to f of x between the lines x equal to a and x equal to b with x-axis. With x-axis. With x-axis is given like this. That is integral a to b mod of f of x dx. This is what we do. This is the more proper way of writing it. Right? Because when we talk about area bounded, we have to add all this area. We have to add this area, and this area. But if you do normal definite integral, what will happen? It will subtract. Above we take positive, below we take as negative. All of you are clear to this part? Okay. So basically, we just have to do definite integral. That's it. We just have to do definite integral. Now, it is not necessary that we always find out area with the x-axis. We always find out area with the x-axis. With the x-axis means here area always have to be bounded. We cannot find out area of a open curve. Right? It does not make any sense. So when we say bounded, here we are bounding this curve with x-axis. Bounding means boundary. It will be one of the boundary of the area. But sometimes we might require to find out area with the y-axis. Let's say it's given that find out this area. Find out this area. In that case, what should be the area? It will be x dy. See, I'll explain it to you what is happening over here when we take this case. In this case, what is the width of the rectangular strips? Dx. A small change in x because you are changing in x-axis. What is the length? Y coordinate. Y coordinate. Y coordinate is fx. Y coordinate is fx. That's why we write f of x dx. Or I can just write the y coordinate. I can write y dx. Both are correct, right? Because this curve is y equal to fx. Y coordinate is the function. X coordinate is the input value x. Now in this, we have to take rectangular strips like this, or I can say horizontal strips. So what will be the width of the horizontal strips? Dy. And what will be the length of it? F of x is y coordinate. Which coordinate it is? Y or x? X coordinate. So it will be just x dy. This will be integral of x dy. Dy is the breadth. And this is the length. Here, this was breadth. And this was length. Clear? Now, if I say a function, if we say we have a function and the function is y equal to f of x. So what will be x? It will be f inverse y. All of you know what is the inverse function? Yes or no? No. Okay. What about you? See, inverse function is opposite of that. For example, we studied sine inverse, cos inverse, cos theta. If let's say, for example, when we say that cos theta is equal to p, so what will be theta? Cos inverse p. So it's a ulta, other way around. Like if you give some x, you are getting a y. That means now you give a y and get a x. So that is inverse function. That is inverse function. So just like we do for cos inverse, sine inverse, this part you know, right? Same thing we do for over here also. If y equal to fx, what will be x? X will be f inverse y. That's it. That is the idea. So that is how we find out area bounded with the axes. Area bounded with the axes. So remember, when you want to find out area bounded with the y-axis, this is with y-axis, and this is with x-axis. This is with x-axis. All of you are clear with this part? Note this one. This is important. All right. You will see examples as well in the NCRT where they are doing both x dy and y dx. In some cases, they might be same. Some cases, they might be different, depending on the question. This part, shall I rub it out? All right. Now, Murugasan, what is the area of circle? Why? Why it is pi r square? But why it is pi r square? See, Newton long back told, right, why apple is not going up, apple is falling down. Why? What force? Gravitational force, right? So there will be some logic behind it, right? Now, you have studied area as pi r square. In which class? So long back that you do not even remember. In fourth, you do not learn pi r square. It is long back, so long back that you do not even remember. Were you ever curious that why it is pi r square? Not curious. No curiosity. Why? Just like apple falling down. Okay, Prithvin, you are not curious ever? Yes. Why it is pi r square? Long back when you were a kid. Dikshita, what about you? Never curious. No curiosity, guys. If let's say some new thing is coming, a new package is delivered at your home, you are not curious what is inside it. Now, now are you curious? Now, are you curious? All right. So your reignited curiosity will get satisfied today using integration. All right. That is what how you derive the area of circle. All right. Integration is a powerful tool. How you derive all the area. You have learned, right? What is the volume of sphere? Is it correct, Pruthit? It is correct. Why it is 4 by 3 pi r cube? All right. All this is integration. All right. I don't know why you didn't have the curiosity, but now is the time for you to satisfy your curiosity if any is left right now. All right. So any left, Prithvin? Like reignited or left from the old times? Okay. So now we will prove area of circle is pi r square. All right. Long back. After 6 years of wait, Murugasan, you got to learn this. Okay. Now, what is the equation of circle with radius r from grade 11 mathematics? Yeah. Any one of you know what is equation of circle? Correct. Now, guys, you remember these three equations: circle, parabola, ellipse, because that will be asked in the question. If you look at exercise 8.1, they won't give you what is the equation. They'll directly say find out this area, that area. All right. If you do not know equation, you cannot start it out. So now equation of circle. I'll do for circle, then I'll teach you other equations. Equation of circle is given as x square plus y square equal to r square. And it represents a circle with center at origin and radius r. All right, Murasan, clear? Still no curiosity why this is the equation? Okay, but you were hesitant to ask that why this is the equation. Okay, now what is a circle? You are giving me very khatanak answers. Anyone who wants to tell what is circle? Equal distance, right? Let's say this is a center. So all the points at equal distance from center. All right. When you were in grade 6, when you learned area of circle is pi r square. All right. At that time, I don't know whether you tried this or not, but there is supposed to be an activity that in which there's a thread. One end of the thread you tie up with a stone or any heavy object. Then do like this. It will form a circle, right? Why? Because length of thread is fixed. Your hand is center. So we say distance from a fixed point is constant, that is radius. Now what is distance formula? Distance between 2 points, x1 comma y1 and x2 comma y2 in normal coordinate. Correct? So let's say if one point is origin 0 comma 0, other point is x comma y. So what will be distance between them? Y square under root. It's same as vectors. mod of vector, same thing, right? So what will be the distance? Root over x square plus y square. This should be radius. So when you square, this will be the equation. All right. So we got equation of circle. Now that we have got equation of circle and we know integration, we know, right? Okay. So can we find out the area? All right. So now we'll find out the area. Now we'll find out the area. Now how we will find out the area? All about this thing. Now can I say that let us find out area only in the first quadrant. Let us find out area only in the first quadrant. Then I multiply it by 4. I'll get total area. Now, how do I find out area under the curve? What? I can do y dx or x dy. If I do y dx, limit will be on x. X is the thing changing, right? Limit will be on the x. So in the first quadrant, if I'm, let's say I'm integrating it. If I'm integrating it, so in the first quadrant, what should be the limit of x? From which x to which x you have to integrate? 0 to r. Because what we are doing is, if we talk about x, x will start from here, this point till this point. Now I have to do y dx. Now this is the equation. If this is the equation, tell me what will be y? Will be root over r square minus x square. So can I say that, like, this is 1/4 in one quadrant. So 1/4 of area will be 0 to r integral of r square minus x square dx. Now I hope with yesterday's lot of practice, all of you must have remembered the formula of root quadratic. Okay, so what is the formula of root quadratic? Correct, that is correct. Yeah, tell me. Plus a square by 2 sine inverse. It is a square minus x square, right? So it will come as sine inverse. Okay, I'll write down the formula so that you do not get confused. It is this. Root over a square minus x square will be x by 2 into root over a square minus x square plus a square by 2 into sine inverse x by a plus c. This is the formula. Now if I integrate it, when I'm integrating it, finally what will happen? This will come out to be as, I can write it as x by 2 into, will get root over r square minus x square plus r square by 2 into, we will get sine inverse x by r, and the limit will go from 0 to 1. Limit will go from 0 to 1. Now we need to put 1. So when you put x equal to 1, what we will get? Sorry, not 1. What I'm doing? R. Now when I put x equal to r, what will be this? This still will become r by 2 into 0. So what is r by 2 into 0? 0. This will be r square by 2 into sine inverse 1. Sine inverse 1 is pi by 2, because sine pi by 2 is 1. So putting x equal to 1, what we are getting? R square by 2 into pi by 2. This is what we got when we put x equal to 1, minus when we put x equal to 0. So when you put x equal to 0, what you will get? 0 plus 0. So in one quarter of circle, what is the area? 4. So area of circle. All right. Finally, Murugasan, after 6 years. All right. Now here we could have also done, see, we are finding out area with the x-axis. We could have also found out area with the y-axis. Like I could have found out this area. Now in this case, it will be same. Why it is same? Because it's area bounded by the coordinate axes. Boundary itself is both x-axis and y-axis. So obviously area will be same whether we do x dy or y dx. So if we do, instead of this, if we would have done integral of x dy, then what would have been limit of y? Same 0 to r. Same 0 to r. And what will be x in terms of y? Similar expression. Root over r square minus y square. That is why here it is identical. If it is bounded by both the coordinate axes. Both the coordinate axis means if one boundary is x-axis, other is y-axis. Then whatever you take, area bounded is same because it doesn't matter, right? This or this. But if I take any other curve, now it will be different, right? Between these two or these two. So if two of the boundaries are both x-axis and y-axis, only then it is same. Got it? Okay. So now I'll write down few standard equations that you should know. Like next is equation of ellipse. Now what is an ellipse? Expanded circle. Okay, where do you use expanded circle? Have you learned about ellipse ever except mass? Physics. Where? Planetary motion. Yes, correct. So equation of ellipse. Did you remember? Okay, I'll tell you. Equation of ellipse. When we talk about ellipse, if the ellipse is like this, center is at origin. So we write it as x square by a square plus y square by b square equal to 1. This is the ellipse. This length, major axis is 2a, and this length, minor axis is 2b. This is the ellipse. You need to remember all these equations not just for area, but also for differential equations. You see in differential equation, they'll give you, tell us differential equation of family of ellipse. That's it. Now you do not know what is ellipse. Leave family. Family comes secondary. And differential equation then gone. Right? So this is ellipse. Next, we will look for hyperbola. Hyperbola equation is this. That is x square by a square minus y square by b square equal to 1. It represents this hyperbola. Center will be 0, 0. And this length from here to here, this length will be 2a. This is hyperbola. Next comes parabola. So parabola equation is this. This rightward parabola is y square equal to 4ax, and this upward parabola is x square equal to 4ay. Now these are some standard equation which you should know. That's it. No need to, you need not to know more than this. Alright. If you have curiosity, then scrub your curiosity for right now. Alright. If you have even more curiosity, then do this after your NEET exam. Alright. But I doubt that much curiosity you will have. Okay. B is basically the length of conjugate axis. which we cannot exactly draw for a hyperbola. Like physically, if you want to feel it, it's not possible. It comes in terms of eccentricity. They might give, might not give. They'll say, like, you find out general, AB. Circle radius is given, you know exact area. If R is given, it comes in terms of R. So area can also come in terms of A, B, like that. Like that, what? Okay. Look, which page of NCRT you have opened up right now? First page. Turn 3 pages, you'll see how to derive area of a general ellipse. All right. In general, will be given to you. You cannot escape it. All right. So can you escape it? No. So if you cannot escape it, then what to do? Embrace it. All right. Okay. So the next example after circle you'll see is find out area of ellipse. All right. So all of you try it out. Do not see how it's given in the book. Do not copy. Try from your own. All right. Try out from your own. Exact same thing. You know the equation. It's given out there on the board. Find out area of ellipse. Again, do the same thing. Find out in first quadrant. Then do into 4. Find out area of ellipse. Pi AB. Be pi AB. Read on your own or through help of NCRT? Are we getting it, Nikita? All right. So guys, what we can do is, like if you are done with it, good. Otherwise, finish it back at home. All right. Try to do this. We'll take another question because this is already given as a solved example, so you can refer it to it. Now, what we will be doing now is that we will be looking into. Okay, we'll take up. We'll take a randomly question. Let's take question number 7. We'll take up question number 7 from exercise 8.1. We'll see how to solve it. Okay, so I'll do it over here on the board. So now in the question number 7, we have to find out area of the smaller part of circle. The circle equation is given as x square plus y square equal to a square. X square plus y square equal to a square. So we have to find out area cut out or area of the smaller part of the circle cut off by the line x equal to a by root 2. That means if we have this circle, now this will be a comma 0 and this point is minus a comma 0. The circle will look like this. Now the line we are talking about will be a, what kind of line? Vertical line, because x equal to a by 2 is a vertical line, a by root 2. So it will be over here. This is the vertical line. Now we have to find out area cut out by the smaller part. The smaller part means we have to find out this area. Now, whenever you come across an area question, all right, solving is one thing, but how you are presenting in the term exam is also important. So 2 steps, never forget. First step will be, you always draw a rough diagram. Diagram will be important because even if your calculation is wrong, if you are drawing a rough means this is a rough diagram. Do not think it's a neat diagram. Rough should not be that randomly you are drawing something. Draw a diagram, it will ensure that you are getting some marks. Pakka. There and then itself. Alright, number one thing. Second thing is, shade the region whose area you want to find out. Shade required region.
So why can't we take this area?
It's given in the question, smaller part. Smaller area.
So according to the question,
Yes, according to the question. Now do this thing. This is like proper steps you have to do. Then normal solving you will do, but these two you have to do in for your term exam. Now that you have done that, now first question arises, how I will find the limits. So to find out the limit, next what you have to do, you have to find the point of intersection. You have to find point of intersection. Now here it will be very simple. So tell me what will be the point of intersection? X equal to a by root 2. It's already given, right? X equal to a by root 2. So you need not to find y coordinate all the over here, but it's a good practice that you find it out. If x equal to a by root 2, put it over here. So what will be y? Y will also be a by root 2. You get a square by 2 plus y square equal to a square. So y square will be also a square by 2. Similarly, this point over here will be a by root 2 comma minus a by root 2. Now again, can we say that we will find out in the first quadrant, find out area in the first quadrant, then we will do into 2. First quadrant means is above. Into 2 will give me the answer. So what we can do is we can write it as area will be twice of 2 times. 2 times we'll do integral of y dx. We'll do y dx because we are finding out with the x axis. Now what should be the limits for x? A by root 2 to a, because we are taking all the values in x coordinate from a by root 2 to a. So it will be a by root 2 to a. Now we have to find out y. Y will come from here, not the value, expression, because we want to integrate it. So what will happen? We'll write it as area will be twice of integral a by root 2 to a, and y we can write it as root over a square minus x square dx. So you have to find out the same, you have to use the same formula. We'll use the same formula.
Then can we substitute the value then we can
If you substitute the value, it will become constant, right? Instead of constant is always the same. Never do that. All right, that is wrong. You understood, right? Why it is wrong? Okay. So this is what we will get. Now using the formula, we can write it as this will come out to be 2 times. Now this integral will be x by 2 root over a square minus x square plus a square by 2 into sine inverse x by a, and we have to put the limit from a by root 2 to a. Now when we put it as a, so putting x equal to a, we will get it as twice will be outside in common. This part will become 0. 0 into anything is 0. For the other, we will get a square by 2 into pi by 2. Then we'll subtract minus. This will happen when we are putting x equal to a by root 2. X equal to a by root 2. Now, when we subtract this, then when we put it over here, we'll get it as how long it was like this? Okay. All right. Fine. Okay. Now that we have got this, so we are done with exercise 8.1. Now there's only 2 exercises in this chapter, 8.1, 8.2. 8.2 is also similar thing, just little bit like different way of doing all of this. All right, so till now we were finding out area bounded with the either x-axis or y-axis. Now we'll find out area bounded between two curves or between two functions. What? Can you check it once? All right. Rasan looks very happy by hearing this.
only area of parabola circle and ellipse.
That's it. Area between two curves are not there.
Second exercise.
Okay, great. Simple. Done this with this chapter. All right. Now I think you are feeling even more confident, right?
Yes, sir.
Good. All right. So just practice this. NCRT is enough for the integral calculus part. Maybe not for vector 3D, but for integral calculus, it's more than enough. Okay. So now we are done with the area. So now we are done with the area. So we'll move on to our next chapter, that is differential equation.
Sorry, parabola only area.
Parabola.
Only area.
Okay. Shall we take up a question on parabola? Okay, we'll take up a question based on parabola. Okay, we'll take up this question. Let's say we want to find out area bounded by the parabola y square equal to 4x and the line x equal to 2. We want to find out area bounded by these two curves, the parabola and the line. So the first thing is always you need to draw a rough diagram. So try to draw it. What kind of para you will get, rightward or upward? Rightward. If you get y square means rightward, x square means upward, y square equal to 4x, x square equal to this and upward. Depends on the square, which one have a square. Yes. So draw the rough diagram. That is the most important part. Draw the parabola, then draw the line x equal to 2. Then see what is the area bounded. Area will be always bounded. Area cannot be open, unbounded. 1 6. Answer. Okay, I'm not sure. We'll check it once. Now what we will do over here is first we'll draw the rough diagram. Now this is the parabola and this is the line. So our required area is this area. Again, we can do the same thing. We'll find out area in the first quadrant and then do into 2. So we'll find out area in the first quadrant, this one. Then we'll multiply with 2. So we'll write twice of. Now what should be the limit on x? If you are doing y dx, we'll get it as 0 to 2. Now what is y? Root 4x. Alright, or I can say 2 root x. Same thing. So we can write it as twice of integral 0 to 2. We'll get 2 root x dx. Now this will be nothing but we will get 4 times root x integral is x power 3 by 2 divided by 3 by 2. And the limit we have to put from 0 to 2. So when we put the limit, we'll get 4 times 2 power 3 by 2 divided by 3 by 2 minus 0. This is when we are putting x equal to 2. This is when we are putting x equal to 0. We'll get this. Now 2 power 3 by 2 is 2 root 2. 2 power 3 by 2 is 2 root 2. So what will happen? We will get it as this. We'll get it as 4 into 2 root 2 divided by 3 into 2. So final answer will come out to be as 16 root 2 by 3. We will get it like this. That's it. We have done circle, we have done ellipse and parabola. Alright, it's very simple. Just be careful of integration. All of you are clear? Any query? Any question? Any doubt? None. Alright, so we'll move on to the next chapter, that is differential equation. Or we'll call it as short form as DE. Differential equations. Now, Dikshita, any idea what are differential equations? Yes. They require some kind of both. Or other way around, we know what is differentiation. We know what is differentiation. We know what is equation. What is equation, Margrasan? Equate. Just put a equal to sign. Throw a equal to sign. It will become a equation. So I want some derivative. I want equal to sign. It becomes a differential equation. Easy and simple. So I'll take some derivative. Let's say I'll write y dash. Y dash we also use to represent dy by dx. So I can say, let's say y dash equal to 2x plus 2. I have a derivative, I have an equal to sign. It's a differential equation. It's a differential equation. Easy and simple. That's a differential equation. You need derivatives and equal to. All of you are clear on this? Okay. Now, first of all, why do we need differential equation? The integration, we said that there we are finding out area. Differentiation, we said, if you remember from the previous term, why do we use differentiation? Slope or instantaneous rate of change, right? Derivative of velocity is acceleration, right? So that was the use of derivative. Now, why do you need differential equation? All right. The idea is simple. You have a family of curves. The family of curve. Now, what is family of curve? Then I say so many curves. Why I say family of curve? Why family? What do you understand by family, Murugasan? What is family? Many numbers are family. If you say this in front of your parents, they'll beat you.
Very closely, close person.
What is that close person? Common relation. All right. So family means something should be in common. All right. So now that common thing, how you are defining it's up to you. All right. Sometimes you'll say my family is only like my father, mother, siblings. Right. Sometimes you also say that my family is this entire Tamil Nadu. All right. Some politician, if you hear a politician, they'll say my family is Tamil Nadu. All right. You see, maybe our president, maybe prime minister, they say my family is entire India. All right. And maybe some others, like someone might say my family is entire world. Someone who might to conquer the world. Maybe Putin might say my family is Ukraine. Right. So it depends how you want to define the family. All right. So that is how we get family. So family should have something in common. That's it. Now, what is that common when it comes to curve? That is the shape. Family of circles means which looks like a circle. Something extra I want to add, then I'll put something. All circles having same center. So all circles having same center will look like how? Concentric circle, right? Same center. I can have circles having same radius, right? So curve having some same shape and some given condition. That makes a family of curves. All right. Okay. So this is in general family of curves. Now, if I ask that Murugasan, you write all the circles, entire family of circles equation you write, how much time it will take you? Huh? More time means how much? 1 day, 2 day? How many days? Or within an hour you can finish? What? How many circles are there in this world? Only one circle is there in the world.
There was a different kind of thing.
Yeah. My question is how many circles are there? Infinity, right? So can you write infinite circles? No, right? Your generation, like maybe your children, your grandchildren, even all of you try different ages. Even they cannot write all the circles, right? So what we can do is we can compress it into a simple equation. That is differential equation. All right. So we are trying to write entire family in terms of one equation. All right. So that is how we do it. All right. For example, if I say I'm defining my family as entire Tamil Nadu. So what you will do? If I say write about my family, will you write each and every name person or you say all people living in Tamil Nadu? Simple, right? So all people living in Tamil Nadu, that is differential equation. Now whoever wants a member, integrate it. Your headache, right? So that's what we do. So for example, if I talk about line is this y equal to mx plus c. Now if I change m, if I change c, I get infinitely many lines. Someone asks me write all lines. I'll say that I'm not going to write. I'll write a compressed form. What is that compressed form? I'll differentiate it. Y dash is m. y double dash is 0. Now I have written all the lines. If you want a specific line, you integrate. All right, that is the benefit of differential equation. You are writing a family of curves with a single equation made of derivatives.
Then that y is equal to mx plus c itself will define that family.
No, but when M and C change, then you get different family members, right? So it is,
Represents family.
no. If M and C are one specifically, it's a family member. No, to write every family member, I have to change M and C. All right. So it's just like we are writing it like this. So that is the idea. All right. Now the thing is, I can make, let's say, I can say I'm changing C, I'm changing M. It's not necessary, right? I can say only lines, a specific type of line. So they will have a different differential equation. All right. So that is the point of differential equation. Now that means differential equation will have two things, right? I have a normal equation, so I can form a differential equation. From normal equation, I have formed a differential equation. Or from a differential equation, I can get a normal equation, right? So in differential equation, there are two parts. First part is forming differential equation. Second is solving differential equation. Forming means normal equation is given, you find a differential equation. Other way around means differential equation is given, you find out normal equation, that is solving.
So y equal to mx plus c is form form
Uh, okay, so we are forming differential equation, solving differential equation. Now, before we look into forming, before we look into forming, we will look into something known as order and degree. Order and degree of differential equation. We'll look into something known as order and degree of differential equation. Yeah, yeah. All right. So we look into order and degree of differential equation. So now the thing is how to find that out and what is order and degree. Okay. So we say that whenever we are finding out the order and degree, like this is a differential equation. So I'll write one or two differential equation. Let's say I'll write y double dash equal to 8x plus 2. Or we will write, let's say, y dash plus y triple dash y dash whole power 8 equal to some ln x. Or let us write something else, some other differential equation. Let us write this one. That is, we are saying sine inverse y double dash whole square equal to 2 plus x. So all these are differential equations because we have a derivative and we have equation, right? So when we, so first we look into what is order of differential equation. Order. So order is simple. It is the highest order derivative. It is the highest order derivative. It is the highest order derivative present in the differential equation. It is the highest order derivative present in the differential equation. It is the highest order derivative present in the differential equation. All right. So what should be order of this first one? What is, all of you know, right? Highest. What is order of derivative? Second order derivative, third order derivative. So what should be order of derivative for the first one? 2. Second one, highest order derivative, 3. It is degree. See, I hope you know that, right? Dy by dx whole square is not d square y by dx square. You know this? Right. My point is velocity square is not acceleration. Alright, derivative of velocity. Derivative of derivative is not derivative whole square. Alright, one second. Alright, so this is what we get. This is what we get. So over here, order will be 3. So I'll also write it down. In the first one, order. Order is 2. Here, order is 3. In the next one, what is the order? 2. So it is the highest order derivative present in the differential equation. It's very simple, straightforward. All of you are clear on this? Okay. After this, we look for degree. So we have seen order of differential equation. Now we have to see degree of differential equation. Now degree have an important catch over here. So we say that if a differential equation can be expressed as as polynomial as polynomial in derivative so in that case we say degree is degree of highest order derivative, degree of highest order derivative. If in case we are able to express a differential equation as polynomial of derivative, then we get degree as the degree of highest order derivative. Now what is polynomial? What is polynomial, guys? What is polynomial? Okay. All right, so we get this as the degree. Now what is polynomial? What is polynomial? Anything power should be a whole number. Its power should be a whole number. Then it's a polynomial. Right? X square is a polynomial. X cube is a polynomial. But 1 by x, why? X power minus 1. What about root x? It's not polynomial because half is not a whole number. All right, so power should be it should be a whole number. So every derivative we should be able to express as polynomial. Like sometimes we have to change the equation a little bit, like take the square, take the cube, but ultimately we should be able to. If you are not able to, then degree won't exist. Degree won't exist. So for example, if you talk about this one, what will be degree for this first one? What degree is the degree of highest order derivative? So degree will be 1. Degree will be 1 because it's a polynomial in derivative. Polynomial in derivative, not in constants, not in variables, only derivative. What about this? It will be 1. Now Murugasan, why 1? What is the highest order derivative? Y dash or y triple dash? What is the power of y triple dash? 1. Degree is 1. What about the next one? Degree will be, now right now it is not in a polynomial. It is sine inverse. Sine inverse is not a polynomial. Sine inverse is not a polynomial. So we have to see, can we convert it to a polynomial? So we'll take sine on both the sides. So taking sine on both the sides, what will happen? This equation will come out to be as y double dash whole square will be equal to sine of 2 plus x. This is what we will get upon doing this. All of you are clear on this part? Okay. Now that we have done this, so we can clearly see now it is defined. So now we'll say degree will be 2. Alright, not always it is possible. No, sine is not a polynomial. Sine is a trigonometric function. Polynomial are algebraic functions. Alright, so it should be a polynomial in derivative. This is not a polynomial, but this is not a derivative. It's a variable and constant. We do not care about that. Now, if I would have been given you this one, that is ln of y dash equal to y triple dash plus 2. Now, can you tell me what will be the degree? Here, degree is not defined. Ln is not a polynomial. It's a logarithmic function. Polynomial are algebraic functions. No, it should be polynomial in all the derivatives. It should be polynomial in all the derivatives. See, polynomial in derivatives, not highest order, in derivatives. All right. It can, variable and constant can be anything. It can be trigonometric, exponential, we do not care. But derivative should be a polynomial. All of you are clear on this part? So that's how we find out order and degree. That is how we find out order and degree. Okay. Now this is very simple. So all of you open up 9.1. All of you open 9.1. We'll do this orally. All right. So we'll have a rapid round. Shall we have a rapid round? What is rapid round, Murugasan? All right. So I'll ask you 1, 2, 3, 4 like this. You have to tell me answer within how many seconds? 10 seconds. 5 seconds. Good. Okay. Murugasan, tell me order of the first one. 9.1 first one. Order. 4. Fourth order, right? Highest order is 4. All right. Uh, Dikshita, tell me the further second one. 1. Prichin, what is the degree of the second one? Yeah. No, 1. Second one, degree. Second one, degree is 1. Prichin, third one, degree. No, degree. 1. Order is 2. All right. Order is 2. Degree is 1. Okay. Murugasan, fourth one, order 2. All right. This is the degree of fourth one. No, not defined. Why? Cos is there. It's not a polynomial. You got a trigonometric function, right? So not defined. Okay. Richard, degree of the first one. Degree. Degree. First one degree. Power of the highest order derivative. No, it is not defined because you have sign of derivative. All right, not defined. Good. Dikshita, order of fifth one. Degree? Degree is defined. 1. See, it should be polynomial of derivative. Sine and cos of variable is accepted, but not for derivative. Only for derivatives. Prithwin, order of sixth one. 3. Degree? 2. Correct. Murugasan, order of seventh one. 3. Degree? 1. Dikshita, order of eighth one. 1. Degree? 1. Correct. Prithwin, we'll jump to 10th one. Exercise 9.1, 10th one. Tell me order and degree. Degree? 1. You have sign y. Y is variable. It's not a derivative. Alright. That's it. We finished exercise 9.1 here itself. In few seconds. Now feeling confident? Alright. Simple. For 11th one. You're asking order or degree? Degree is not defined. Yes. Okay. So this is what we get. All of you are clear on this? Okay. Now we have talked that the essential part of differential equation are two things: forming and solving. Now, whenever we are forming a differential equation, you just have to be careful of one thing. What is that one thing? You have to remove arbitrary constant. That is the only aim when you are forming differential equation. You have to eliminate arbitrary constant. Arbitrary constant. That is our only aim. Wasn't clear? Then tell me what is arbitrary constant. And then you should ask, right? 3x is not arbitrary constant. Constant. Now, what do you understand arbitrary? Okay. Arbitrary means some random, you can say, right? Random. Constant is constant. Now, if I talk about equation of circle, if equation of circle is x square plus y square equal to a square, or I say equation of circle with radius 2, if radius is 2, it will be x square plus y square equal to 4. Now, what is x? A variable. What is 4? Constant. What is a? What is a? A is the arbitrary constant. Arbitrary constant means a constant whose value is not given. I have some A, B, C, D, P, Q. Alright, so what is our aim? To eliminate arbitrary constant. Now, how to do that? How to do that? That is the important thing. Now, tell me what is the derivative of arbitrary constant or any constant? 0. So, we differentiate and we eliminate it. We differentiate and eliminate it. So, when I differentiate this, what will happen? We'll get it as 2x plus 2y dy by dx equal to 0. Now this will become the differential equation of these circles. These circles means with center at origin and radius is some arbitrary constant. Alright, so what is the only aim? Arbitrary constant. In the second one, how will you form the differential equation? Is there any arbitrary constant? No. 4 is a fixed constant, not an arbitrary constant. Arbitrary constant means value you do not know, but it's a constant. So how you form differential equation? No, you won't form a differential equation. Tell me, what was your purpose of forming differential equation? Family. Is it a family? It's a member, right? If you say that, see, if you come to me and say, sir, like I'm Murugasan, in my family there's only one member. I am my family. What will I think about you? Something wrong, I'll say, right? Okay, so that is the thing over here. So for a single, there's no point of talking about family, right? So that is why there's no need to do that.
That is first order degree one, sir.
This first order degree was correct. All right, so that is how we form differential equation. Now, if you look into the next exercise, that is exercise 8, 9.2. In exercise 9.2, it has been given that you have to verify, you have to check whether the equation and differential equation are matching or not. Whether the equation and differential equation are matching or not. So what you have to do, you just have to differentiate and see. See, for example, I have given this equation of circle. I have given this differential equation. I'll ask you, are they matching? They are matching, right? If I give you some random differential equation, then it's not matching. So given equation, you differentiate and you check whether it will match it or not. All right. Whatever is our aim is to eliminate arbitrary constant, right? That you forget for now. All right. Ideally, I should not differentiate this because no point of doing that. But in the question, if it is asked, okay, whether it will form this or not, you just differentiate and check. All right. So, for example, if we take the first question we'll take. In the first question from exercise 9.2, exercise 9.2, if we talk about the first question, in the first question, what will happen is that it is given, that we have y equal to e power x plus 1. Now we have to verify whether it is a solution of y double dash minus y dash equal to 0 or not. All right. So then what happened? We'll look at that later. First, you look at it over here. All right. Now we have to see whether it will be satisfied or not. So what we need to do? We differentiate. Find out y dash. Find out y double dash. What is y dash? E power x. What is y double dash? E power x. What will happen when you subtract these two? Let's prove. That's it. That's it. So this is entire exercise 9.2. All right. So this is the idea. It's relatively simple. All right. So I hope you can do the remaining questions. Can you do the remaining questions, or shall we take one more example? What? No, it's not that we cannot do rapid fire over here. All right. It will take some time for you to differentiate. If you are good at differentiation, like we can do. Are you good at differentiation? Shall we do a rapid fire? Vishita, shall we do a rapid fire? Okay, we'll do 2, 3 questions rapid fire. All right. Prichin, second one. Exercise 9.2, second one. It is correct. Murugasan, third one. Well, correct. Dikshita, fourth one. Okay, we'll differentiate it. No, no. Derivative of constant is 0. See, when you differentiate, you get y dash equal to minus sin x. Take sin x on the other side to become plus sin x. Dikshita, fourth one. Fourth one maybe you have to write. Fourth one, all of you are getting fourth one. What will happen? You put the value of y. So x is x, y will be root over 1 plus x square upon 1 plus x square. So y dash will come out to be as x divided by root of 1 plus x square, which will be true. Fourth one, all of you got it right? Okay. Okay. No, no. What is y dash given? Y dash is given as xy by 1 plus x square. Now tell me what is y. So I'll write root over 1 plus x square. Now can I cancel out one of the roots? So what will be y dash? X by root over 1 plus x square. Now y was root over 1 plus x square. What will be derivative? It will satisfy.
Same here. Differentiation. So you should multiply only terms. So 2x will become.
Then multiplying 2 is right. Any question, any doubt? None. Okay, we'll continue with the rapid fire. Prithvin, fifth one.
Sir, y dash is here, sir. So ax equal to y, sir. So
Let's satisfy. Correct. All right. Murugasan, sixth one. Or we'll do one thing. This rapid fire is not rapid anymore. All right. It is just becoming very slow fire. So you finish remaining at home. Idea is clear, right? If you do rapid fire, our syllabus will become slow fire. So we'll move on to the third one. Now, exercise third one, 9.3. That is purely based on forming differential equations. All right, here we have to given both the things, but now we have to form the differential equation. So here we have to exactly form the differential equation. Here we have to exactly form the differential equation. Now, what was the aim when forming differential equation? Eliminate the arbitrary constant. That is only aim. But before you start eliminating it, always remember one thing. Try to write in the minimum form, like minimum possible arbitrary constant. See, for example, I'll say that you have to do for this. That is y equal to ax plus b plus c plus d. Now, how many arbitrary constants are there? What all are there? A, B, C, D. Yeah, but they are unnecessary. I have made extra. So what we'll do? I'll club these two, these three, and I'll write it as y equal to ax plus k. A is arbitrary constant. Anything which is not a variable, which is a constant, but you do not know value, is arbitrary constant. Any you first of all you do not know x. X is a variable. What about a? Constant. Do you know the value of a? Arbitrary constant.
2x square would be also arbitrary constant.
Do you know the value of 2? Array, 2 is 2. So 2 is a fixed constant.
So yes, suppose we have bx square plus y square equal to a square, then bx square would be also arbitrary constant.
B?
Bx square plus
B x square is not arbitrary constant. B is arbitrary constant. B is arbitrary constant. X is a variable.
so ax is arbitrary constant.
A is arbitrary constant. X is variable.
Yes,
All right. A is arbitrary constant. So this is what we get. Now, so you always reduce number of arbitrary constants. Do not unnecessarily try to expand it. If you can club it, merge it, and make it smaller, do that. That is first step. That is first step. So, for example, if I write equation of line is this. That is ax plus by plus c equal to 0. So how many arbitrary constants are there in equation of line? There are two. How to? I'll divide this entire equation with c. So what will you get? Some k1x plus k2y plus 1 equal to 0. So always minimize your arbitrary constant. Always minimize your arbitrary constant, then you do it. All right. Now another important result.
previous question also y minus ax minus k divided by k.
So then y by k will become new arbitrary constant. Right. So when we are solving, this is our aim. All right. Our aim is to eliminate arbitrary constant. Now another very important result comes from this, and that very important result is that we say degree degree of a differential equation is same as number of arbitrary constant in the original equation. Sorry, not degree, order. I said degree, right? Okay, order. I was looking at myself that how YouTube is coming. That's why I said order as degree. Okay, so we say that order of differential equation will be same as number of arbitrary constant in the original equation. In the original equation. All right, so this is what we will get.
So first exercise is also you can do this
Which one?
by finding how many number of arbitrary constants.
That is not even given in exercise first one. Directly differential equation is given. All right. Okay. All of you are clear till this part? Okay. Now why should be order same as number of arbitrary constant? Okay. How do I eliminate arbitrary constant? By differentiating. So if there are two, I have to differentiate two times. There are three, I have to differentiate three times. That is the order of derivative will be same as number of arbitrary constants. All of you are clear on this? Clear? Now we'll take a question that how the question will be there from this exercise. All right. So let us take this question. We have to find out differential equation. We have to find out differential equation of all family of circles. Of all, we have to find out differential equations of all family of circles having center at the line y equal to x. Having center at the line y equal to x. So now what is the first thing you need to know over here? Now, what will be equation of circle having center at the line y equal to x? Only when you find that you can find out differential equation. Now can you find that out?
2x square plus
What?
2x square equal to h.
Why? Center is at x comma y. Center. What is center of x square plus y square equal to r square? 0 comma 0. How can center be r? Center will be a coordinate.
So x minus a that y minus b.
It will be, so what will happen over here? Any point on the line y equal to x, how can I write? Any point on the line y equal to x, I can write h comma h. Like same coordinates. Same coordinates. Now for those of you who do not remember their conic sections or equation of circle, ellipse, this will be the biggest challenge for you. Alright, because this knowledge is required, it won't be given. Alright, so this exercise, that is 9.3, you might find out a little bit difficult, but try it out. Just go through examples. Once you go through examples, right, that knowledge will be complete. Like all what will be the basic equation, what all variation can be there. All right, rest will be just changing a little bit here and there. So now this is the thing. So if let's say radius is r is also arbitrary constant because radius is not given. If it would have been given radius is 2, then it would have become a fixed constant. So now equation will be given like this: x minus h whole square plus y minus h whole square equal to r square. Equation of circle is a distance formula. That's it. Take the square of distance formula, you get equation of circle. What will be distance between center and any point, x comma y? Under root, take the square. So the equation of circle is simple. Distance formula, you put it directly, you get. Now, Dikshita, how many arbitrary constants are there? 2. They are h and r. They are h and r. So our aim should be to eliminate the arbitrary constant. So you can clearly see, right? When I differentiate for the first time, r will directly go away. Easy. So first I'll differentiate one time, then I'll see what to do later. So we'll differentiate it first time. So what will be the derivative of this? X minus h whole square twice of x minus h plus twice of y minus h into dy by dx. That we will write as y dash. This will be 0. This we will get it as 0. Now that we have got this, what we can do? Either I can isolate h and then differentiate. But remember, how many times maximum you can differentiate? 2 times. Do not try to differentiate more, even if you are not getting the answer. If you are not getting the answer, try to rearrange it, then simplify. But do not unnecessarily differentiate extra. Because extra differentiating means you are adding extra members to your family. Alright. It will be more like, let's say your parents told you, okay, you invite all the family members. Alright, and you are giving call to everyone in Coimbatore. Or my family is Coimbatore, like that. So something wrong will happen to you, right? So like that. So do not differentiate extra. If arbitrary constant are 2, maximum differentiate it 2 times. Alright. So how will we do that? Like either we can isolate, that is one way of doing that, we can isolate h. Or let's say I do not want to isolate, I'll just directly differentiate this. I'll find out the value of h and put it back. So let us differentiate this. So what will be derivative over here? 2. What will be derivative over here? It will be 2 times y double dash into y minus h. We have to use the product rule. Fx into gx or uv rule. U. What is the derivative of 2x? Why it will go away? Alright, so we'll get it as 2y double dash. First derivative of this one as it is, plus derivative of first one, that is y dash, and second one as it is, y dash, equal to 0. So when we further simplify it, what? We're using product rule. Derivative of y minus h is y dash into other is already y dash. Product rule. uv dash plus u dash u. So what will happen? We can write it as 2 plus twice of y double dash into y minus h plus y dash whole square equal to 0. So we can simplify it. 2 will go away. It's 0. So we can take it out and with 0. So we will get this thing. We will get it as y double dash into y minus h is minus y dash whole square. Yes or no? Okay, 1 will be also there. Correct. So we'll also do minus 1. So what will happen? We can write h minus y will be equal to 1 plus y dash whole square upon y double dash. So what will be h? Y plus 1 plus y dash whole square by y double dash. Now do not differentiate again. Why? 2 times you already done. How I will find differential equation? By substituting this value of h over here. Sometimes it will go big. Alright. You want to go big in your exam, right?
Recording in progress.
If you want to go big in your exam, you have to go big. Alright? Go big in exam, go big in life. Alright, Murgasan? Okay, do not differentiate third time. Put the value. Sometimes it will be easy by keep on differentiating, sometimes not. Alright. This is like one of the difficult question I have taken from this exercise. Easier will be easier to differentiate. All of you got it? Alright, so this is forming differential equation. Just check once if anything is deleted in this one also. So that's all about forming differential equation. After forming, we have to do solving. Forming is relatively easier because we are differentiating. Solving means integration. Hmm? All right, I'll check it later because I think we'll be only able to do one type. That one type definitely is there in the syllabus. All right, other types we won't be able to do it today. So we'll move on to solving differential equation. All right. You are taking so much time that in that time you must have finished the topic which is related.
For next of differential equation whose general solution is given, solution of linear differential equation of type dx by dy plus dx equal to q.
So that means entire thing is there.
So why we should put h in this equation?
See, because there is no equation till now which is free of h. Our aim was to eliminate h, and we cannot differentiate it further. So this is our only choice.
You can put that in first equation.
But in first equation you get r square. R square is arbitrary constant.
So if you put in equation where only that h alone is
Yeah. Just the idea is remove arbitrary constant. All right. Okay. So now we will quickly look into the solving part. We will look into the solving part. So in solving part, we know that we have to integrate. We have to integrate it. So solving can be done in three different methods. That is variable separation, variable separation. Then we have homogeneous, and then we have linear. All right. There are three different methods to simplify a differential equation. We'll be able to do max variable separation today. Remaining two we'll do later. Now, as the name suggests, what we have to do? Look at the name. What you can feel? You have to separate the variable. That's it. Easy and simple. Take all the x together on one side, all the y together on the other side. That is variable separation. Then integrate it. So let us take a differential equation. We have been given x square by y dx equal to dy. Now, can I integrate it directly? Why not? Yeah, y is there. I do not know how to integrate y with x because we do not know y. If I would have known y, then no point of doing this, right? That itself is solution. So we do not know y. So what we'll do, we'll separate it. We'll take all the y on one side, all the x together. So we'll get it as x square dx will be y dy. Now next what we need to do? We just have to integrate it. It's already differentiated. We have to solve it. Solve means come back from differential equation to normal equation. So we'll integrate on both the sides. We'll integrate on both the sides. So what will be the integral of LHS? X cube by. What is RHS? S square by 2 plus C. That's it. This is the idea of variable separation. You separate the variables, then integrate it. All x on one side, all y on the other side. So we'll take question from your NCRT, move on to 9.4. Move on to 9.4 and we will take question number. Okay, we'll take question number 7. We'll take question number 7. In question number 7, we have y log y dx minus x dy. We have y log y dx minus x dy equal to 0. So we have to simplify this. Again, the idea is same. Separate the variables, all x on one side, all y on the other, then integrate. Okay. Log y they have been haunting us for a long time, right? I asked you 2 days back. No, yesterday. 2 days back. Log y integral.
Product log y into 1
By parts. But here you do not have to integrate log y.
1 by log
You use substitution. Log y is t. 1 by y dy will be dt. So what we will do over here is that okay, what we will do is that we'll separate the variables. So we can write it as y log y dx. This will be equal to x dy. So we can further simplify it and write it as dx by x will be equal to dy by y log y. Now next what we will do is that this is direct integral. We can take it as ln mod x. Over here we will take log y as t. Over here we'll do the substitution. We'll take log of y as t. So we'll get 1 by y dy. This will be dt. So this will become dt by t integral. So what will happen? They will get this thing as log or ln t we can write plus now t value you can put log y. So this is what we do in variable substitution. All right, all of you are clear on this? So that is about variable separation. So now we'll stop over here, and there are only two things left: homogeneous and linear. It won't take much time. All right, so we will cover this together with vector 3D tomorrow. All right, so you have to finish everything till 9.4, including area 8.2, 8.1, and including integration if you have not finished it. All right, so how much work? More work. Okay. All right, so you have some work and you have to finish it. All right, finish it completely. I'm telling you, if you finish NCRT completely, right, 35 will be like easy. All right, so that's it for now, guys, and see you later.